Now, in this third topic, we'll be studying about more about electrical energy and power. Okay, so I hope that if you are able to keep pencil and notebook in front of you, because we are going to write some formulas. This whole topic is all about formulas. Okay. Now, we have already known about energy in the second chapter, work, power, energy. So, from work, power, energy, we'll be taking power and energy, okay, in this part. So, energy is existing in various forms such as mechanical, heat, chemical, and electrical, light, nuclear, okay. So, according to the law of conservation, then energy can be transformed from one form to other, but it can neither be created nor destroyed, okay. So we have used many devices where electrical energy is converting into other forms such as heat, light, mechanical, chemical, sound, and magnetic. We have already studied this. Now, what about electric heater, oven, or geyser? If you pass electric current through a heating element, okay, the element is made up of an alloy. So because of the resistance, it gets heated up, and therefore energy gets converted to heat energy. Therefore, we are getting like heater, oven, or geyser, which like what we require from these appliances, we require heat energy. So electric energy is converted, okay, to heat energy in these appliances. What about the bulb? So okay, how does this heat energies, like how does this energy get converted? Because of resistance, that you remember, okay. On passing electric current through an electric lamp, the filament gets heated to an extent that it glows. So we have already studied about which element is there in the filament of the bulb. कौन सा है? Tungsten.
Copper.
नहीं,
Oh,
tungsten. So the electrical energy thus changes into the light heat energy and light energy. उसका resistance इतना high होता है that it glows. Okay, the third one, on passing electric current through an electric motor used in fan, mixer, and juicer, the coil and attachment with the axle of coil begin to rotate, and simultaneously the coil gets slightly heated up. The electrical energy gets converted into mechanical energy and small part into heat energy. Now this you are aware in case of mixer and fan. Okay. Okay. What about electrolysis? Like battery, इलेक्ट्रोलिसिस की बात नहीं कर रही हूँ, बैटरी की बात कर रही हूँ. On passing electric current through electrolyte, a chemical reaction takes place. Okay, the electrical energy gets converted into chemical energy. Then loudspeaker में we have studied electrical energy gets converted to sound energy. Okay, now what about this? An electric current in a coil wound around a soft iron bar, the bar gets magnetized and becomes an electromagnet. We have studied this topic in ninth. In this case, electrical energy gets converted to magnetic energy. I hope you understood. When you have a
yeah.
soft iron bar and the coil is wound around that, the bar gets magnetized when you are passing electric current through that coil, and it becomes electromagnet. Okay, so ठीक है, we know about it. Now the whole thing, please, I would request you everyone to write it down. Okay, so first of all, we need to understand the electrical energy. Now electric energy is that work only. If you remember, हमने work पढ़ा था. What is the work का क्या था work? If you remember, potential. What
F
was
cos
potential?
theta.
हाँ, potential क्या था? The work done in getting the positive charge from infinity to a particular point. याद है? ऐसा कुछ तो था ना? So W is equal to,
Yes.
और याद है V is equal to W upon Q. The first topic of, so in this case we can write W is equal to QV. Okay. Now what is Q? Okay, I is equal to Q upon T. ये भी याद है. So can I write Q is equal to IT? Okay. तो Q की जगह पे what will be writing? IT. और V तो है ही. So it will be VIT. Okay, understood? Now,
Yes,
in
yes,
this
ma'am.
in this case, can I write mm, V के जगह पे can I write IR, Ohm's law? Okay, तो V के जगह पे मैंने IR लिखा, then it will become I square RT. ठीक है, समझ में आ रहा है कि नहीं? Okay, in place of I, can I write, okay, what is I? V upon R. Okay, I की जगह पे can I write V upon R? Okay, so it will be what? V square, okay, R upon, तो एक काम करते हैं, V square RT upon R square. ओके, तो आर आर कैंसिल, आंसर क्या हो जाएगा? एक आर कैंसिल हो जाता है, इट विल बी वी स्क्वायर टी अपॉन आर. समझा क्या?
Yes,
Yes, ma'am.
ओके, so let's see. मैं अभी यहाँ लिख रही थी, let's see. So what is electrical energy? Electrical energy is the work done. So if there is a resistance R, let the current I be flowing from the resistance R, and the potential difference is V. So by definition of potential differentiation, work done needed to move the charge Q through a potential difference is W is equal to QV. Q की जगह पे I have applied IT, then the next formula is W is equal to VIT. ठीक है? Work done is the electrical energy. Okay. Now Ohm's law क्या है? V is equal to IR. So substitute V के जगह पे put IR. तो क्या आ जाएगा दूसरा फॉर्मूला? I square RT. Now in this case I के जगह पे apply V upon R. Again the Ohm's law only. Okay, then the other formula क्या है? V square upon R square. R cancel, तो आंसर क्या आएगा? V square T upon R. So how many formulas are there?
3.
4. Okay, so W is equal to QV, VIT, I square RT, V square T upon R. Now I will request you to remember the derivation. जैसे मैंने अभी बोला, Q के जगह पे apply VI, V के जगह पे apply IR, तो I square R, I के जगह पे apply V square upon R. Remember the derivation, नहीं तो ये समझेगा नहीं. You cannot mug up so many formulas. Just mug up only one formula, that is W is equal to QV. That's it. Okay. Now, what will be the SI unit of electrical energy? Joule. All energies are Joule only. Work done भी Joule है. Now, let's understand the power. ये हमने already पढ़ा हुआ है. So, electric power and its expression. What is power? W upon T. Okay. Rate at which the electrical energy is supplied by the source. Fine. So W upon T, अभी हम देखते हैं फॉर्मूला. इसका भी we have to study the derivation because we need to know. So power is what? W upon T. W की जगह पे what you will be writing? QV. मैंने अभी भी बोला एक ही फॉर्मूला याद रखो. W is equal to QV. Q के जगह पे apply IT. TT कैंसल, तो आंसर क्या आएगा? ओके, IT तो दिख रहा है ना. तो पावर का नेक्स्ट फॉर्मूला है VI. ओके, ये तो इंपॉर्टेंट ही है. पावर का फॉर्मूला है VI. नाउ I के जगह पे अप्लाई V अपॉन R, तो आंसर क्या हो जाएगा? P इज इक्वल टू V स्क्वायर अपॉन R. देन V के जगह पे अप्लाई IR, तो I स्क्वायर R स्क्वायर, तो आंसर आएगा I स्क्वायर R. Now just remember, there is a difference between electrical energy and power. Now power is what? With respect to time. So in the formula of power we don't have T. There is no formula, मतलब T है ही नहीं. Only एक ही फॉर्मूला है W/T, उसमें ही है, बाकी दूसरे फॉर्मूला में T नहीं है. But what about electrical energy? In electrical energy, we have time in the formula. If you see VIT, I square RT, V square T upon R, remember this. तो कभी कंफ्यूजन हो गया कि मैं कौन सा फॉर्मूला लिख रहा हूँ, व्हाट यू कैन डू, टी का याद रखना. इलेक्ट्रिकल एनर्जी में टी है और पार में सिर्फ W/T है, बाकी कोई भी फॉर्मूला में टी नहीं है. व्हाट इज इलेक्ट्रिकल पावर का फॉर्मूला, ये यूनिट. So if you see, it is
Watt.
joules, हाँ, joules per second. So it is watt. Joules per second, it is watt. और वोल्ट एम्पियर. सो यू हैव 3 यूनिट्स. तो तीनों राइट है, वोल्ट एम्पियर भी राइट है, वॉट भी राइट है, जूल्स पर सेकंड भी राइट है. सो व्हाट इज 1 watt? 1 watt is the electric power consumed when a current of 1 ampere flows through a circuit having a potential difference of 1 volt. Okay. Now what is the higher SI unit? 1 kilowatt. क्या है? 1000. 1 megawatt, 10 raised to 6. 1 gigawatt, 10 raised to 9. Okay. Any doubt in this case?
No, ma'am, no doubt.
Okay. Commercial unit of electrical energy. Now we are talking about electrical energy commercial unit. Commercial मतलब जो हम लोग bills pay करते हैं. The SI unit of energy is joule. If an electrical appliance, now we are talking about another way. We are not talking about electrical energy. We are talking about commercial electrical energy. So if an electrical appliance of a power P watt is used for T second, like तुमने अभी television use किया. Now television has some watt, okay, some power, and you have used it for some seconds, or you can say you have used it for some minutes or hour. So what will be the electrical energy consumed? Now this we are talking about consumption. How much the appliance has consumed. तो याद रखना ये वाला फॉर्मूला अलग हो जाता है ना. दिस फॉर्मूला इज W is equal to power into time. So watt into second. So this is the, we are talking about electrical energy consumption by the appliance. ठीक है. Now how can we measure in second? So they have given another bigger unit in hour. Now any appliance सेकेंड पकड़ के बैठेंगे या घंटे में देखेंगे. सो दे हैव गिवन the whenever we measuring the electrical energy consumption, we are measuring it in watt hour or kilowatt hour, kWh. Okay. So what is 1 watt hour? Very important, एग्जाम में आता है. 1 watt hour is the electrical energy consumed by the appliance of power 1 watt when it is used for 1 hour. Now, how do you convert? What is the relationship between 1 watt hour and joules? Okay, 1 watt उसको वैसे का वैसे रखा. 1 hour के लिए just write it in seconds. 3600 seconds, 60 minutes into 60 seconds. So 3600 joules. Exam में ये आ चुका है. This also has come. Okay, 1 watt hour is how much? 3600 joules. What is 1 kilowatt hour? 1 kilowatt hour is the electrical energy consumed by an appliance of power 1 kilowatt when it is used for 1 hour. Okay. Any doubt? Now, what is 1 kilowatt hour? 1 kilowatt converted into watt, that is 1000, and 1 hour can be converted into 60 minutes into 60 seconds. So it will be 1000 into 3600. तो इसको ठीक से लिखेंगे तो it will be 3.6 into 10 raised to 6 joules. Okay, you can mug it up because exam में fill in the blanks करके आता है. 1 kilowatt hour dash कितना है, कितने joules है? 3.6 into 10 raised to 6 joules. Okay. So the consumption in our house, okay, or in any industry, it is measured in kilowatt hour. Okay, and we are paying the electricity bill based on kilowatt hour. कि आपने महीने में कितना कंज्यूम किया है. Okay, any doubt? Okay, so P is equal to V square upon R. So R is what? V square upon P. ठीक है. So R is equal to V square upon P. So this is going to be the permanent formula. Again, what we are talking about? We are talking about electrical appliance. उन्होंने पूछा what is the resistance of the electrical appliance when it is 100 watt and 220 volt. तब आपको ये करना है. Okay, now how can we calculate the current? एक फॉर्मूला है पार का. कौन सा फॉर्मूला है? P is equal to VI. So can I write the I is equal to P upon V? ठीक है. So if यहाँ पे लिखा है if current exceeds this value, the power supplied at voltage V will exceed the rated power and the bulb may get fused. Okay, समझ में आया क्या? If the current is exceeding, what will happen? The power will increase. Power will increase, the bulb will get fused. So this value of current is called safe current. Okay, तो जो भी रेटिंग दिया हुआ है अपॉन वोल्टेज रेटिंग, मतलब P अपॉन V. Let's do this. कैलकुलेशन थोड़ा सा डिफिकल्ट पड़ता है बट वंस यू रिमेंबर हो जाता है. लाइक इफ द बल्ब इज रेटेड एज 100 वॉट एंड 220 वोल्ट, रेजिस्टेंस ऑफ द फिलामेंट क्या होगा? V square upon P, 220 square upon 100. Okay, because 100 watt is there. आंसर इज 484 ohms. अभी ये कैलकुलेशन करना में बहुत इंपॉर्टेंट मतलब डिफिकल्ट पड़ता है. इफ दे आर गिविंग यू दिस देन जस्ट रिमेंबर इट इज 484 ohms. नाउ दिस इज कांस्टेंट. हाँ, क्योंकि ये बल्ब चेंज नहीं हो रहा है ना, बल्ब का रेजिस्टेंस कांस्टेंट ही रहता है. नाउ लेट्स कैलकुलेट दी सेफ लिमिट. सेफ लिमिट के लिए क्या है? I is equal to P upon V, that is 100 upon 220. Answer is 0.454 ampere. That means approximately 0.5 ampere. Okay, so if my current is increased more than this, तो बल्ब तो उड़ जाएगा. Okay, thus the bulb can withstand current of 0.5 ampere. If the current is exceeding 0.5 A, it may cause the bulb to fuse. At a voltage higher than the rated value, excessive current will flow through the filament, which will raise the temperature to the extent that it will melt and the bulb will get fused. समझ में आया? Okay. The power consumed by bulb will be equal to power rating only when the bulb is connected exactly at the voltage rated on it. Okay, if the voltage at which the bulb is connected is slightly more, the bulb will glow more brightly. That is, it will consume more power. And if the voltage is low, the bulb will glow less and it will give faint dull red light because it will consume less power. देखो मैक्सिमम कितना है? 220 वोल्ट. ओके, इससे थोड़ा मैंने ज्यादा इंक्रीज किया तो थोड़ा ब्राइटली होगा, लेकिन उससे ज्यादा करोगे तो बल्ब विल गेट फ्यूज्ड ना. 220 वोल्ट के जगह पे योर करंट, अभी जैसे अभी मैं गांव में हूँ. ओके, सो डू यू थिंक कि मेरे को 220 वोल्ट मिल रहा है इधर? नो, आई मे गेट इन 110. इससे सब चीज स्लो है. द बल्ब इज स्लो, मतलब वेरी, इट्स ग्लोइंग वेरी लाइटली, पेंट एकदम. ओके, नाउ दिस इज अ वेरी इंपॉर्टेंट एग्जांपल कि मैक्सिमम तो पता चल गया, बट व्हाट विल हैपन इफ इट इज लेस. सोचो 220 वोल्ट इज द मैक्सिमम थिंग, यदि मुझे सिर्फ 110 वोल्ट मिला, ओके, तो व्हाट विल बी माय पावर? कितना कंजम्पशन हो रहा है? लेट्स इवैल्यूएट दैट. कैसे करते हैं ये? लिख लोगे क्या? यहाँ पे ठीक से दिया नहीं है. फर्स्ट ऑफ ऑल दे हैव गिवन यू bulb is 100 watt and 220 volt. ये तो उसका कैपेसिटी है. कैपेसिटी मतलब मैक्सिमम इतना कर सकता है. ओके ओके, So 100 watt to 20 volt. Now from this, first of all, try to get the resistance, because bulb का resistance पहले मिलना है, because that is constant. क्या है formula? V square upon P, right? तो आंसर क्या मिलेगा आपको? कैलकुलेशन नहीं आ रहा है तो इफ दिस इज द गिवन देन 484, हाँ यहाँ पे लिखा है 484 ohms. नाउ उन्होंने बोला that if bulb is rated this much, okay, तो रेजिस्टेंस है. Now if the bulb is lighted at 110, okay, अभी लेकिन मुझे अभी गांव में कितना मिल रहा है? 110 मिल रहा है. तो my voltage is now 110 volt. Then what is the power? ये क्वेश्चन है. What is the power? तो फॉर्मूला क्या है पावर का? इज इक्वल टू V स्क्वायर अपॉन R. तो V स्क्वायर की जगह पे आई राइट 110 Can you hear peacock's noise? Okay, we have a lot of peacocks here. Okay, so 110 ka square upon 484. When you calculate, you will be getting 25 watt. Now, so when the maximum voltage is 220 volt, my power consumption is maximum 100 watt. Okay. तो उसमें से मैंने क्या किया? बल्ब का रेजिस्टेंस निकाला. बट नाउ इफ माय वोल्टेज इज 110 वोल्ट, व्हाट विल बी माय पावर? इट विल बी just apply the 110 square upon 484, we will be getting 25 watt. That's it. Now if my, यहाँ पे उन्होंने दिया है if my consumption is okay, if my voltage is 250 volt, okay, can you hear anything?
तो गिर रहा है.
Okay, just 1 second. Okay, so when my voltage is 250 volt, so let's apply the formula. Formula is what? V square upon R. तो क्या करोगे? V के जगह पे apply 250, okay, upon R. R क्या है? R is constant 484. So approximately if you calculate, यहाँ पे देखो दिया है आंसर 129.1 watt. Okay, so if you can see, मेरा maximum voltage क्या था? 220. तो मेरे को कितना मिल रहा था पावर कंजम्पशन? 100 watt. Now if I have decreased, what will happen? My power consumption will be 225 watt. If I increase, my power consumption is 129.1 watt. So you can see what happens. So this is very important example. Please mark it. Okay, I hope you understood. Bulb की resistance constant रहता है. Okay, power can vary based on the voltage, but the resistance will be same. ठीक है?
Yes, ma'am.
Any doubt in this case? Okay. Now household consumption of electrical energy. Now this part we had studied in 8th standard. I hope you remember. मुझे नहीं पता. तभी मैंने पढ़ाया था. मुझे पता है इसलिए. So electricity has an electric meter which measures the amount of energy consumed by various appliances in that house over a given period of time. The electric meter is fixed at the mains board or just outside your house. हमारे इस घर में बाहर है, but in Kumar Paradise we used to have below like नीचे रहता है ना एक क्या वो some sort of room is there where all the meters are connected. I think you must have seen. I don't know. Okay, the electrical energy is sold in units in kilowatt hours. Okay, तो हर एक का consumption वैसा ही होता है. And we pay according to the kilowatt hour. The unit in which the consumer pays the cost of electrical energy is kilowatt hour. Okay, this comes as a fill in the blanks. Now, the electrical energy consumed by an appliance in a certain time can be calculated in kilowatt hour. Energy in kilowatt hour क्या रहेगा? Power into time. मैंने अभी बोला था there is another formula when you are talking about electrical energy consumption. It will be represented as E एंड उसका फॉर्मूला है पार इनटू टाइम। ठीक है, टाइम पार क्या रहेगा, पार विल बी टेकन इज एज किलोवाट आवर and time will be taken in 1 hour. Okay, so if you see there are three formulas, it can be taken in watt also if it is given in watt. जैसे अभी पंखा, पंखा तो किलोवाट में नहीं दिया जाता, it will be giving कि आपका पंखा 60 watt का कंजम्पशन है। so how do you convert in kilowatt hour upon 1000? इसे देखो दिख रहा है इधर, power in watt into time in hour upon 1000. Okay, now there are some appliances, they are given in not in watt, they are given in volt and ampere. That means वो appliance का ना watt दिया नहीं है, उसमें ना voltage कितना है और current कितना आ सकता है maximum वो दिया हुआ है। so पार का
मैम
फॉर्मूला क्या है?
टाइम।
yes, पार का फॉर्मूला क्या है? vi, p is equal to vi. so there is another formula, vit upon 100. okay, so let's join back.